Thank you. It's a real pleasure to be here. It's been my good fortune throughout my career to work with Quanta and QCT for many years, and it's very gratifying to be here as part of Q.synergy and to see so many old friends. What I'd like to talk to you about today is give you a little taste of the latest in data center innovations from AMD. And although we focus on both the GPU as well as the CPU, I'm going to focus here today on that product that Mike talked about, codenamed Rome, our latest second generation EPYC server processor. And you know, the server processor, Rome, is our second generation, and I'm super pleased to say that since the beginning, since the first generation, we've been very pleased to have the support of QCT as one of our many ecosystem partners. But QCT has particular relevance for us because they actually were the company that helped us with our internal reference designs. So we knew when we had to introduce a part with the sophistication of EPYC and coming back into the market in a major way, we needed a great partner that would help us develop the part that really matched the system needs of so many of the customers in the cloud space. And so we've had a long-standing long-standing partnership with QCT, with many of the first-generation clouds powered by AMD EPYC, doing so on Quanta platforms. And so thank you, Mike, JJ, the whole team, for your support on that. And more importantly, for today, we've continued to expand the partnership and expand the range of solutions that are available to you on QCT platforms powered by AMD EPYC. And the AMD EPYC second generation processor is, I think, a real watershed moment in the industry. It is a culmination of many years of work at AMD, first building up a new CPU roadmap, beginning with our Zen 1 core, which we launched in servers about 2 years ago. But with the second generation, we've really taken it to a whole new level. AMD EPYC second generation, or Rome, delivers record-shattering performance with over 100 world records now claimed by EPYC. It entails a real breakthrough in system architecture as well, or chip architecture, using a novel combination of chiplets where up to 8 die, split between 7 nanometer devices and 14 nanometer devices working in concert, provide an incredible capability within one CPU socket. And I think really pointing the way towards the direction that all server processors are going to take, and many other large data center components are going to take over time. And with that level of capability, EPYC offers, in conjunction with great platforms from QCT and others in our ecosystem, truly disruptive total cost of ownership that can really fundamentally change the cost of the services that you provide to your internal or external customers, allowing you to reinvest in your business, to reinvest in innovation, or to pass along savings to your customers and so accelerate your business and revenue. And we think because of that, because of the innovation in architecture, because of the world record breaking performance, and because fundamentally the TCO that it offers, EPYC truly is the new standard for the modern data center. Now, we wanted to do things a little bit differently. You know, coming back into the data center, we're coming back into a market that we really hadn't participated in a major way for a while. And that, you know, one that was really dominated by a very credible and capable company, Intel, of course. And so we needed to innovate and to provide new thinking, new opportunities for our customers. And so as we defined EPYC and came back into the market, we tried to define 2 paths. The first path for unmatched performance was the traditional path, the path of 2-socket servers, where with the second generation EPYC, you get that world record shattering performance, the ultimate performance you can achieve in a 2-socket server today. But we also took another path. We decided to introduce the concept of the no-compromise single-socket server, where the capabilities of a single piece of silicon were not shackled or hampered in any way by artificial restrictions on performance or features. And by doing so, it allowed our customers to right-size their servers for their workloads, for their applications, in an optimal way. And I'll show you more of that in just a second. And so those two paths are two paths that are supported by some great platforms from QCT, as we'll talk in a minute. Well, the first path is the path of performance leadership. And as I show on the slide behind me, with the second generation EPYC, we support up to 64 cores per socket using the latest in 7-nanometer silicon technology. And by doing so, we can offer unmatched performance capability and throughput performance that truly breaks the mold, offering up to double the performance of the latest generation of components from our esteemed competitor, and offering a really disruptive capability, not just at the top of the stack, but even down the stack, with 32-core EPYC processors, again, outmatching all of the alternatives. And so truly offering a wide range of performance, and for HPC, for throughput applications, for even applications such as networking or storage, the dual-socket EPYC offers an incredible scalability to address problems in a way that you couldn't address before. On the single-socket side, we didn't shirk. I said this was a no-compromise single-socket play. And if you look on the right, a single socket of EPYC up to 64 cores, again, offers all of the performance of the dual-socket Intel alternative. And what does that mean? That means that the answer to the question that I began getting 2 years ago when we first introduced this concept of the no-compromise single socket, the question of what is a single socket good for? I've been working with 2-socket for a long time. Forrest, you're messing with my program here. What's a 1-socket good for? Well, 1-socket is good for, quite frankly, almost anything, because the single socket EPYC delivers all of the performance you can get from a 2-socket alternative. And so no matter what your workload is, you can look at now a more cost-effective, more power-efficient alternative in a denser form factor as well. And so giving you a new choice, a new option for your data center consideration. And it really spans a wide variety of workloads. So, you know, if you're talking about storage or networking or some sort of embedded applications, I think the value of the single socket configuration is clear. But even in a more traditional enterprise deployment scenario, it provides incredible advantages. So in this particular example, we take a look at a fairly typical on-prem deployment of a large VM cluster. So 3,200 cores, you know, supporting a large VMware farm, not dissimilar from what many companies have deployed today in their on-prem data centers, or for that matter, what many hosting companies provide today as a cloud service for end customers. With single-socket EPYC, you can deliver that performance, the same level of performance or better, same number of cores, and you can do it instead of a gold processor from perhaps an alternative. You can do that with 50% fewer physical servers, where each one is a single socket rather than a dual socket, so 75% fewer CPUs, driving 62% lower power. And in this particular example, the VMware software is licensed per socket, 75% lower software licensing costs. And when you put all that together, what you get is a reduction in total cost of ownership for that VMware farm, all in OpEx and CapEx, by 45%, nearly halving the cost to deliver that level of performance, internally or externally, for a long period of time. That is disruptive economics. That is reshaping what you can do in your data center for a given watt, for a given dollar. It really allows you to do new things and allows you to invest in innovation with these savings. So we think this is an incredible opportunity for everybody. And we're seeing many customers embrace. So I was pleased to stand was pleased to have one of our lead customers, Twitter, stand on the stage with us last month at the Rome launch event in San Francisco, announcing that Twitter is embracing, will be deploying single-socket EPYC servers. In their particular configuration, they claimed, of course they don't have the same software licensing issues that others might have, 25% reduction in TCO, all in, which again, from their point of view, is transformative. And so that level of TCO advantage, coupled with the performance advantage you get from these very dense 64-core throughput machines, gives you tremendous opportunities. For those of you that are in the cloud business, the other opportunity is, quite frankly, containers. As people move more and more to microservices, as Mike said just a few minutes ago, that's becoming increasingly important. Microservices based on containers and managed by Kubernetes is a huge deployment scenario. AMD EPYC scales up in containers better than twice the efficiency as the alternative, and again, offering a far richer container density in a given rack for a given watt for a given dollar. So huge opportunity for anybody who's looking for a new choice in your cloud data center. And I'm particularly proud to be standing on this stage here today because, as I mentioned earlier, Quanta was instrumental, QCT was instrumental in helping build the reference design that we use to shatter many of those world records and to develop the second generation EPYC system. So if you look at the Daytona system, which many of you may have because we sampled it early on, that's a system designed by QCT to really highlight all of the capability of second generation AMD EPYC. And so they know how to make that processor sing, to unlock the full performance of the cores, to give the maximum speed available in today's server market in terms of memory speed, and of course to deliver full PCIe Express Gen 4, which today is only available via AMD-based systems in standard 2-socket or 1-socket server systems. And so the praise for the QCT AMD-powered system was great to see. And again, I just want to thank Mike, JJ, the whole team at QCT. You guys did an awesome job on that platform. Thank you very much. And it doesn't stop there with our reference design. I'm particularly honored as well and humbled by the fact that QCT has a rich set of AMD EPYC-powered systems that will be available here through the next several months, with 5 systems offering a range of capability from single socket to dual socket, from 4 nodes in 2U to rich storage-dense options that provide a great fit for almost any workload that you might have, be it a cloud front end, be it a database, be it a storage or networking application. QCT has got a great option for you that really showcases the full performance and full capability of second generation AMD EPYC. And so I'd ask you to, I think many of these are going to be out in the demo zone, and I'd ask you to take a look at these. And so to wrap up, I just want to again thank Quanta for your partnership over the years and support, and hope that you all will take a look at the Quanta systems powered by the AMD EPYC processors, because we think they do offer a compelling alternative and really are trying to bring choice and innovation back to the data center in a real way. And with that, I'd like to just wrap up by thanking again our hosts and turning it back over to the moderator. Thank you very much.